Hi guys, how we doing? Sorry I can't be in class with you today. What I want to do with you today is I just want to quickly show you guys how to predict a compound's formula based on the charges that you find on the periodic table. Okay, this isn't terribly difficult. It requires a little bit of 7th grade math, least common multiple, and a little bit of multiplication, but we can handle this. All right, check this out. Here's how it works. Here we got sodium and chlorine. What we know from the periodic table right now is that sodium forms an ion that is a 1 positive ion. We also know that chlorine forms an ion that is a 1 minus ion. Okay. Now, in order to accurately predict how these two ions are going to form a compound, we just need to realize that a positive and a negative ion are going to attract each other, and they're going to form a compound once they've attracted and actually stuck together. Okay, it's kind of like two magnets coming together and touching each other. Sodium's a magnet, chlorine's a magnet. They're going to hit each other on they're going to touch each other, oppositely charged, and they're going to actually form this compound, what we call sodium chloride. You guys know it, it's called table salt. Now, the way to actually do the math on this is pretty simple. Okay, I'm going to show you this. It's going to be extremely simple with this one. It uses the idea in math of least common multiple. Now, if you don't remember what this is, 1 has a least common multiple. Actually, I can't say that 1 has a least common multiple, because in order to do a least common multiple, I need something that's in common, so I need two numbers to compare. I can say that 1 has multiples of 1, 2, 3, 4, 5. Multiples are just whole number multiples of the number you're starting with. So this is kind of a boring one, because the least common multiple of the other one is 1, 2, 3, 4, 5. If we want to get technical here, these are all negative values, and these are all positive values. Okay, but I'm not going to get technical on this. All right, the least common multiple that we're looking at here, between 1 and 1, the least common. This is the least common, right? Number 1 is the lowest common multiple. Okay, some people call it lowest common multiple instead of least. What that means is I'm going to write a 1 down here and a 1 down here, since that is actually the LCM, the lowest common multiple. That means that we got a total charge of 1 negative and a total charge of 1 minus. These are where my total charges are written. See, this is a bar indicating total. All right. Now, 1 times what value, how many, gives me 1? Well, that's simple. I only need 1 times 1 to give me positive 1. Okay. The math over here, 1 times what value gives me negative 1? Well, negative 1 times what value gives me negative 1? Well, 1. Okay. Now, if you're looking at this, you realize that what's above this here bar is a charge and a number of atoms, or a number of ions in this case. We got a charge and a number of ions. So when I actually write this, I write NaCl as a compound. As a compound, it doesn't get any charges written down in the upper right-hand corner. And I do write how many of each that I have, but in chemistry, if you write down an element symbol, it's assumed that there's one of them. So I don't have to write down a 1 after this. I just write down Na. And I don't have to write down a 1 after the Cl, because I just assume that there's 1 chlorine. If I don't write an element symbol, I assume there's none of it. All right, with calcium and chlorine, let's try a similar approach here. Calcium is a 2+ ion because it's in the alkaline earth metals. Chlorine is a 1 negative ion because it's a halogen. We got to work on the LCM here, the lowest common multiple. So calcium has common multiples of 2, 4, 6, 8, and there's an infinite number of more. Chlorine has common multiples of 1, 2, 3, 4, 5, and still an infinite number more here. Okay, so what I'm looking at is, as far as a common multiple, 2 is common. It's the lowest common one in both of them. So I'm going to use a 2 positive as my total positive charge, and a 2 negative as my total negative charge. Now the question I ask myself is, what number times 2 positive gives me 2 positive? 1. Okay. What number times 1 negative gives me 2 negative? I say that's 2. 1 negative times 2 gives me 2 negative. All right. If I want to test this here, the compound in total should be able to add up the math. 2 positives plus 2 negatives equals 0. What we know about all matter is that it's neutrally charged. So this is going to give me a neutrally charged compound when I do this. What that means is that when I write down my final answer here, I'm going to need 1 calcium. Again, I don't need the 1 because when I write Ca, it's understood. And then I write Cl, and I put the 2 here because I need to say that there's 2 of these chlorines. Magnesium and oxygen. Magnesium, still a alkali metal, 2 positive. Oxygen, 2 negative. Lowest common multiples of 2 include 2, 4, 6, and 8. Lowest common multiples of the other 2 include 2, 4, 6, and 8. So I'm looking at a 2 negative and a 2 positive here. Okay? One of each is going to give me what I need. 2 times 1 gives me positive 2. 2 times 1, actually negative 2 times 1 gives me negative 2. So my LCM wound up being 2. I wound up adding those up to be 0. And I only needed 1 magnesium and 1 oxygen. So I'm going to write down MgO. Notice, guys, this is not the same thing as MgO2. MgO2 says I've got 2 magnesiums and 2 oxygen atoms in 1 compound. This says I only have 1 of each. So the picture would look kind of like this, Mg and O together. This picture over here would look a little bit different because it would be MgO, Mg, and O. This compound is distinctly different from that one. This one up here is wrong. This one down here is correct. Last example here, strontium and nitrogen. Strontium is a 2 positive. Nitrogen is a 3 negative. Okay. Least common multiples, we're talking about 2, 4, 6, and 8 for 2. And we're talking about 3, 6, 9, and 12 for 3. So that means that commonly they have 6 in common. So I'm going to go for 6 positive here and 6 negative here. LCM, because nature is nice that way. Sometimes our mathematical concepts show up in nature. 6 positives, 6 negatives is going to give me a total of 0 for a neutrally charged compound. Now the only problem is figuring out how many of each I need. 2 positive times how many gives me 6 positives? Well, that's easy. 3 sets of 2 give me 6, right? And how many sets of 3 are going to give me the negative 6? I need 2 sets of negative 3. Okay? So my final answer here, this is going to be strontium 3, nitrogen 2. Okay? And I just pronounced that strontium nitride. Hopefully this clarifies things for you. Work on your review today also, guys. Make sure that you get that done and that you understand it. Don't just copy off of me and don't just copy off of somebody else. All right? If you can do the review, remember, you should do pretty decently on the test.